Now take a look at how we can use our trig functions to represent real life type questions. So trig applications. So tides in the Bay of Fundy cause the water level to rise 6 meters above average sea level and to drop 6 meters below average sea level. So it happens every 12 hours, making it a periodic function. So we can draw this from the specific information that we have, and then we can figure out a sine, or in some cases cosine function, that represent that situation. So first of all, what we want to do is draw a graph that represents this situation. So it tells us that at low tide, the depth of the water is 2 meters. So what we're going to be doing, we're going to graph our time versus height graph. So time is going on the bottom in hours, and on our vertical axis, we're going to have our height in meters. So our low tide, the depth of the water is 2 meters. That's the lowest that it can be. And it's going to go up to 4, 6, 8 is our average. And 10, 12, 14 is our maximum. Okay? Because 2 meters, it's still 2 meters high at the lowest. The middle is 6 meters above that. The maximum is 6 meters above that. Now, we want to draw 2 cycles of this. So the water is at average sea level at midnight, and the tide is coming in, meaning it's going to get deeper. So we know that at midnight, it's at 8 meters. It's at the middle. Now we're going to draw our graph. We want 24 hours, which means that in a 12-hour period, if this is going to look like our sine function, we're going to go from the middle to the max, to the middle to the min, and back to the middle in 12 hours. So 2 cycles is going to give us 24 hours. So on our x-axis, we're going to have to split these into 3-hour periods. So each 12 hours is split into 4 sections. So we're going to have 3, 6, 9, 12. Another 3, 6, 9, 12. So that's going to get us to 24 hours, and it's going to go up 3 hours every time. So at 12 hours, we're going to be back to the middle, and at 24 hours, we're going to be back to the middle again, because each cycle takes 12 hours. Well, that means that it's going to be at its max at 3 hours. As the tide goes out, it falls, gets back to the middle, or the 8, at 6 hours, and falls to the minimum of 2 meters at 9 hours, and is going to do the same thing in our second cycle, max, back to middle, and down to the minimum. So our nice, round, smooth curve for sine, and we know that that arrow is going to continue. Okay, so now we have our graph. What we want to do is, the next part is going to be coming up with an equation for the graph. Now we want to compare what we have to what our base sine function looks like. So we know that our base sine function starts at the middle and goes up. So the x-axis is the middle of our graph, and that's what we want to compare to what we have as well. So we're going to draw our line in the middle of our graph because that's our sort of starting spot, would be the x-axis. And our graph starts right at the middle, which this one does, which tells us that there is no vertical translation. There is a vertical translation. There is no phase shift though. Okay, so where our normal graph would have started at 0, 0, it's now starting at 0, 8. So that's our vertical translation. So we have our base point has moved up 8 units. We also want to take a look at, and let me just start with writing an equation for the graph. We're starting with our base function of y equals a times sine k theta minus d plus c. And again, remember that d and the c can be an h and a k. It can be represented by anything. We just have to know what it means where it's placed. So we need to calculate our a, our k. We already said that c, or our vertical translation, is up 8 units. Okay, so we're going to have a plus 8 at the end. We had no phase shift, or D, meaning D is 0. We still need to figure out that amplitude and our K value. So amplitude is the max minus the min divided by 2. So our max is 14 minus our minimum of 2 divided by 2, which is going to give us 6 units. And that makes sense graphically as well, because if we look at the middle of our graph, it goes up 6 units and down 6 units either way. Okay, so we know that our amplitude is 6. Now we want to figure out our K value. And remember, our K value comes from our period. So we know that one full cycle happened in 12 hours. We're going to use that to figure out our K. So we know that if we think about our period, we calculate it as 2 pi over K. Well, K then is equal to 2 pi if we just switch those two. Remember, we talked about K is 2 pi over P. So we're going to have 2 pi over P, in this case, is 12 hours. And simplifying that, both top and bottom divided by 2, we're going to have pi over 6. And this is measured in radians. We could also do this in degrees. 360 divided by 12, get our value and put that in. We just see most of these functions with that radian measure in there. So we now have our amplitude, our K value, our C value, and our D value. We can therefore state our function. So we're going to have y equals 6 sine pi over 6. And notice we don't have any phase shift, so it's just going to be x. There's no x minus or plus anything. And at the end, we have our plus 8 for our vertical translation. So we want to compare our base graph to where it has moved, if it's stretched, what our amplitude is, and get all of those measurements and sub them into our equation. Now, we also want to be able to use our equation to figure out the depth at any time. Well, if we're talking about the depth of the water at 1400 hours, so from midnight, 14 hours have passed. So what we're going to do, and again, that's our x value, so we're going to sub in here 14 for x. Now, we have to be very specific about how we're putting this into our calculator. Our pi over 6 times 14 is what's giving us the angle. So we first of all want to punch that into our calculator. So pi button divided by 6 times 14, get our answer for that. Then we're looking for the sine value for that. And again, make sure that your calculator is in radians because we're using radian measure here. So in radians, pi divided by 6 times 14 sine. Then we can multiply by 6, then add 8. So we're still finding or using BEDMAS to do this. Just remember that this has to be an answer for our angle first, then our sine, multiply by 6 plus 8, and we should get 13.2 meters, telling us that the water is 13.2 meters deep at 1400 hours. And remember that that makes sense because it hits its maximum at noon. So just after noon, it should be just below that maximum of 14 meters. So we always want to think about, does our answer make sense to what we have drawn as well? Now, part D, if the water is at average sea level at 2 o'clock and the tide is coming in, write an equation for the graph that shows how the depth changes over the next 24 hours. So again, if we think about how our original graph has changed, let's think about what the difference is. So we're still talking about our 2, our 8, our 14, and we've got our 12 hours, 24 hours. So we're just going to sketch this. So our original graph looked like this. Okay, this was our original graph. The difference is that now this starts at 2 hours. So our graph is just going to be behind 2 hours. So that means that if we follow this back here, we have gone down a little bit, and now we have our middle. We still have our vertical translation of 8 units. We still have our period of 12. The only thing that changes now is that we have a phase shift to the right 2 hours. That's the only change to our graph, which means that our equation is just altered by what's in the brackets. Y equals sine pi over 6. Now we have x going to the right, means that it's a positive value and it stays x minus 2 plus 8. Okay, so again, the only difference is that we now have a phase shift of 2 hours and we have x minus 2 in our brackets. Okay, so we can use our sine function to represent any real life examples where a cycle continues and follows that pattern every time. And that's where you may have seen that we measure light using sine, we use sound using sine. All of those cyclical things that happen can be represented by our sine or our cosine function. Noticing that if we wanted to use our cosine function, we would just use our maximum value,